All right, on number 10, instead of drawing out their structure, they give us a structure and we have to name it. So we're going to do similar to what we were doing before. We find our longest chain of carbon, we find our branches, we find our functional groups. With the functional groups, it changes our suffix. And we also have to tell where those functional groups are located. So with letter A, we have to find our longest chain. If we look, it's just straight across. We have 5 carbon. And then we have a methyl branch. And then we have this OH. So we're going to name our branches first. CH3 is methyl. It's located on the second carbon. I'll write it down here. So 2-methyl. Okay, so now I'm ready to name my chain. But the first thing I have to do is tell where my functional group is located. So if we count, that alcohol is on the third carbon. There are 5 carbon total, so that's pents. It's all single bonds, so I'm going to put AN. And then if I look at my foldable under name, it says OL. So letter A is 2-methyl-3-pentanol. All right, letter B. We pretty much do the same thing. We find our longest chain, so it's just going left to right. We have a methyl branch here. We have a double bonded oxygen that's within the chain. Be careful on this one. If you look in your foldable, you see 2 different ones that have just one double bonded oxygen, and that's a ketone and an aldehyde. And you probably should make a note somewhere on your foldable. Ketones are within the chain, aldehydes are on the first carbon of the chain. So since this one is on the third carbon, this would be a ketone. We always have to name our branches first. We have a methyl branch. Our branch and our ketone are both closer to the right-hand side of our structure than the left-hand side. So I'm going to start counting from the right. So our methyl is located on the second carbon. So 2-methyl dash. Now we're ready to name our chain. Our ketone is on the third carbon. So that's 3 dash. There are 5 carbon totals, so that's pents. There's all single bonds in between the carbons, so that's AN. And then if you look in your foldable at ketones, the name says ONE. So that is 2-methyl-3-pentanone. C doesn't have a functional group. It just has a double bond. And that CH3, that branch on the bottom, is actually should be attached to the second carbon. I know it looks like it's in between. It should be on the second carbon. Look at letter D. So now we have a double bonded oxygen, and it's on the very end of our chain. So remember, we can either count from left or right. If we count from the right-hand side, that double bonded oxygen is on the very first carbon. So now we have an aldehyde. On D, we don't have any branches, so we don't have to name them. So if it's an aldehyde, it's always on the very first carbon. We don't have to put where the aldehyde's located. That's understood. So we have 4 carbon in a row. Prefix for 4 is bute. We have all single bonds in between our carbons, so that's AN. And then aldehydes end in AL. So butanal is letter D. E, we've already done an alcohol. F, you have 2 double bonds. So don't forget to put diene, D-I-E-N-E, at the end of your chain. 11, you're doing the same thing. You have a fluoro, and you'll treat it as a branch on 11A. 11B, you have bromo that you would treat as a branch. I don't know what happened to C or D. 11E, you have OH, which would be an alcohol. Letter F, you have a chlorine and a double bond. All right, 12. Each of the following formulas can be written as two compounds with different functional groups. Write the structural names in the compounds and identify the functional groups. So you are going to do isomers here. So you're going to write as many compounds as you can using 2 carbon, 6 hydrogen, and 1 oxygen for letter A. You're going to draw them out, then name them, and tell me what functional group that was. You'll do the same thing for B. And then do the same thing for C. You might have to put some double bonds in there because you don't have enough hydrogen. Oh, I found 11 C, D, G, and H are on my next page. Okay. So you still have C, D, G, and H for number 11. But those are problems that I've already done or ones I'm about to do on 13. So flip over to 13. You might have to come back and finish out 11. All right, we've done aldehydes, ketones, alcohols, carboxylic acids. So let's skip down to I, cyclohexanamine. So that prefix cyclo tells me it's a shape. Hex tells me that that shape's going to have 6 sides or 6 points. AN tells me that that shape's going to have all single bonds. And amine, so if you will go to your foldable and look up amine, you will see that it is a nitrogen group. It has 3 dashes off of it. So what that means is that nitrogen has to bond 3 times. It's going to bond once with our hexagon. And then we don't have anything else for it to attach to. So just like with carbon, we fill in the rest of it with hydrogen. Or you could also write it as NH2. Either way. So that is cyclohexanamine. We do not put a circle inside of our hexagon. If we put a circle in it, that means we have a double bond on every other side. And we don't on this one. It has that AN after hex, so that means single bonds. So we don't need any double bonds. We don't need a circle inside of our hexagon. Letter J, 2-aminobutane. So let's start with the chain. That's bute. That's 4. 2-amino. So amino is another way, another prefix that they use for amine. So that means on the second carbon, we're going to put a nitrogen. Remember, nitrogen has to bond 3 times, and it's only bonded once. So we can put it as NH2. And then you're going to fill in the rest of your bonds with hydrogen. Letter K, 2,4-nitrophenol. On this one, that phene tells us phenyl. So remember, phenyl is a branch of a benzene ring. So benzene is a hexagon with a circle inside of it. OL tells us that it's an alcohol. Nitro tells me NO2, and that's not one that's on your foldable. So we're going to put in our alcohol, and then on carbons 2 and 4 we have nitro. So NO2 and then 2-9-O-2. So that is 2,4-nitrophenol. On letter L, there's a little bit of an error. It says 1,3-nitrobenzoic acid. Well, if you remember when we did a carboxylic acid a few minutes ago, they're always on the very first carbon. So that 1 doesn't really need to be there. Benzoic acid, so benz tells me benzene ring. So I need another hexagon. Oic acid is a carboxylic acid. It's going to be on the very first carbon. Which one is the very first carbon? Whichever one we want it to be. The problem here, it's a carbon with a double bonded oxygen and a single bonded OH. I can't put this, because if you remember, this circle means that we have double bonds on every other one. So the carbon that's at this point right there already has 3 bonds. It can't have 4 more. It can't have 6 bonds total. It can only have 4. So this is kind of an exception to the rule, and one of the only exceptions you'll see in organic. We have to attach a carbon and then a double bonded oxygen and an OH. And this only happens with carboxylic acids that are attached to some kind of shape. All right, so the carboxylic acid is on the first carbon, and then we put a nitro on the third carbon. So that is our 3-nitrobenzoic acid. All right, and then letter M, ethanitrile. So we know S means 2. AN, we have a single bond. Nitriles, this isn't on your functional group, or your foldable either for functional groups. Nitriles are nitrogens that have a triple bond. So we're going to draw 2 carbons that have single bonds. And then on one of those carbons, we're going to draw a triple bonded nitrogen. It also has 2 leftover electrons. And then this first carbon only has 1 bond, so it needs 3 hydrogen. Our second carbon has 4 bonds, so it's good. All right, so I think we're good on 13. 14, you're drawing structural isomers. So C6H14, you can draw any structures you want as long as they have 6 carbon and 14 hydrogen. So you might draw a chain of 6 and then add 14 hydrogen. You might draw a chain of 5 and put a methyl branch on it. You could draw a chain of 4 and put an ethyl branch on it. When you put those branches, make sure you don't put them on the first carbon or the last carbon, because then it just becomes part of the chain. So once you draw out 5 of them, go back through and name them. On 15, you're just drawing them out. There's nothing out of, there's no functional groups in those. 16, you're writing out names, and there are no functional groups in those either. 17, I only see double bonds in 17, so there's no functional groups. 18, you're drawing out the structure. B, you have 2 double bonds, but no functional groups. And then 19, let's see, I see some chlorines or some chloros. Be careful on B when you name it. There's a Cl3, so you have 3 chlorines. So that would become a trichloro. And I think that's it. Um, so especially with those functional groups, if you struggle through them, just try to draw as much as you can. Uh, Make sure you at least draw the chain. Once you get the chain drawn, then you can go back and start adding things that need to be attached to it.